It's difficult for us humans to fully comprehend the enormity of space. We are comfortable in our own cosmic neighborhood, the solar system, and are used to familiar faces like Jupiter, Mars, and of course, Earth. But out there, over 18 billion kilometers away from the Sun, and beyond the heliopause, is the cold oblivion of interstellar space. The two Voyager probes are the only man-made objects ever to cross this threshold to this day, and until recently, only two known objects have ever made the opposite journey, passing from interstellar space into the solar system. These were the famous Oumuamua in 2017 and Borisov in 2019, which brought with them the thrill, and perhaps even fear, of being visited by something from the depths of space that humans cannot hope to reach in our lifetimes. In the 6 years since these visits, we've been enjoying some respite, but a recent observation has forced us to sit up and pay attention once more. I'm Alex McColgan, and you're watching Astrum. Join me in this video as we explore all there is to know about NASA's latest observations of Comet 3I Atlas, the third interstellar object ever observed, which will make its closest approach to our Sun before the year is out. 3I Atlas has had a few different names in the short time we've been aware of it, but recent revelations about where this object came from and where it is heading turned this otherwise indistinguishable space rock into something worth taking note of. On the 1st of July this year, the NASA-funded Atlas Survey Telescope was performing its usual task of scanning the skies above for moving objects. The Atlas project, or Asteroid Terrestrial Impact Last Alert System, consists of 4 telescopes across Chile, South Africa, and Hawaii. These telescopes each take around 800 images every night, and at the time of writing, they have registered 1,212 near-Earth objects that will pass within 1.3 astronomical units of our planet at perihelion. But on this particular night, the telescope in Rio Hurtado, Chile, reported some newsworthy observations. The Atlas telescopes are rather unique for their ability to survey the galactic plane, the bright, disc-shaped region of our galaxy where most of its mass lies. See, other surveys like Pan-STARRS and the Catalina Sky Survey are often too sensitive to photograph this area without facing overexposure, so they tend to avoid it altogether. From the direction of the Sagittarius constellation, the Atlas telescope took 4 30-second survey images and found an object that was making a beeline towards our solar system. The object was initially named A11PL3Z and quickly caught the attention of the Minor Planet Center in Cambridge, Massachusetts. As the designated authority in charge of labeling and tracking minor bodies in the solar system, the MPC quickly put out an electronic circular about this new visitor, detailing all of its previous observations and providing information about its trajectory. In doing so, astronomers realized that, in fact, this object was no stranger to us. As it turned out, the Zwicky Transient Facility in California and the other 3 Atlas telescopes had all made pre-discovery observations of this object, dating back as far as the 14th of June. With all of this data, the MPC deduced that the object had a hyperbolic and highly eccentric orbit, so much so that it had originated from interstellar space. This realization earned the object the name of 3I Atlas, as it is the third interstellar object to infiltrate our solar system. At first, the MPC could not be certain whether this object was an asteroid or a comet, until the combined data revealed that it had a coma, a diffuse halo of dust and gas produced when ice is exposed to solar radiation and sublimates. This feature is far more typical of comets, which gave this object yet another name, C2025N1. The MPC has called for additional observations of this comet to help constrain its trajectory, so we can expect a flurry of new data in the upcoming months, and astronomers are, naturally very excited. Michelle Bannister, an astronomer at the University of Canterbury in New Zealand, explained that working on the